Alright, let's do the question number 80. So the question number 80 is try to find the rate expression first. And remember that the rate expression is always in a form. Rate is equal to some constant times the reactant concentration. But we don't know the power associated with each one of these forms. These are all reactant, okay? All of these guys are reactant. And what we need to know is to find out the power. For example, what is the power of A, power of B, power of C, right here. So let's just think about that one. The power of A. So going from the condition 1 to condition 2 right here, there are two things that's been changed, right? This thing changed, this thing's changed, right? And I don't want any of those things that's related by more than two things being changed. So I'm gonna erase that one. Try to erase that. Okay. So let's think about some other things. What would be the good one? The second one and the third one look like there is only one thing being changed, right? These are concentration of B and the concentration of C didn't change, but concentration of A being changed. And going from 3 to 2, you increase the concentration by factor of 2, right? And then what happened to the rate here? 2.4 divided by 2.4 and 9.6, so equal 9.6 e to the negative, what is this, minus 6 divided by 2.4 e to the negative minus 6. So 4 times, right? So the concentration increased by factor of 2, but rate increased by factor of 4. That means that this rate is having a power of 2 right here. Okay. What about the B right here? There are some conditions that only B changed. So let's think about that one. So what I can't see. Looks like not. So here it's same for each one of these guys, and then these guys. Okay, that's good. Alright, so concentration of A4, that one is same, and the concentration of that C is this one is same, right? And then concentration of B going from here to here, it's been changed by factor of 1.5, but rate is staying exactly the same, right? When that's the case, this is actually 0. although the concentration of B changed, but the rate itself didn't change, while being other concentration being fixed, right? Only concentration of B changed, but the rate didn't change. So this is the power of 0 right here. That's the only way you can actually do that. So that's that. So that we can actually ignore change in concentration of B from this point on, because it's power of 0, right? So I don't care about that one. Then let's just think about the concentration of C changed, but other things being consistent. And we don't care about B. So let's do that. So I know that the concentration of C changes this one, 20. And then I just need to look for the 20 being changed to 40. Not to 40. That's not right. Maybe this one. Concentration of this guy, A didn't change, but concentration of C changed by 3 times, right? And for the rate by itself actually changed by 3 times right here, right? So condition 3 to condition 4, the rate has been increased 3 times by increasing the concentration of C by 3 times, while other things being consistent. And that means that this one right here is linear, meaning that this one right here is actually 1 right here. So okay, so we got that one to be K times A squared e to the power of 0. Well, actually, so we can actually ignore this one, right? Because anything to the power of 0 is actually 1. C to the power of 1. Why did I actually circle that? Pen is not working very well. Let's see. To the 1, right? And we can pretty much ignore B right here. So that's that, right? That's the rate. The rate expressions. So let's just actually plug in the numbers and see what's going on here. So the rate expression for each one of these is fine. So I'm going to take the condition 1 right here. 2.4 e to the negative 6 is equal to K times 0.2 to the power of 2 multiplied by 0.2, right? I'm going to equal this one. So what is K here? And K must be equal to this divided by that. Alright, so that's pretty much explain everything. So rate is actually equal to k times a square c square. K times a to the power of square times the c concentration of c. So let me just write out the final answer. Actually, why don't I actually do that with Excel? Equal 3e to the negative 4 multiplied by a squared c. Alright, so that's what it is.